Hello guys, welcome. In today's video, I'm going to show you how to use the PCA9685 in an advanced way. Here you have these two files, the .cpp and .h, which are, it is what is going on when you're including the Adafruit library to use it, for example, on an Arduino. And I am also using the same structure to make my PCA96 work on my STM32. So you have a lot of functions here, but the two main functions that I'm interested in here are the set PWM frequency and the set PWM function. So let's start with the set PWM frequency that we have here. And as you can see here, this section of the code is basically the same here as in my own code. Now, when you're using I2C, here you have a read from this register, and you have all the registers here, the definition of all the registers. So the thing is, you start by reading from this register. And in I2C, you cannot read without writing because it's a slave master protocol. So you have to write first by addressing the specific register you want to talk to. So you're gonna send some data into that, starting with the address of the PCA9685 first, and after that, you're gonna address the register that you want to talk to by writing the value of this register in the data you're going to send. Based on the experience I had with that, I realized that for it to work, you must receive a zero from this register. And if you only send the value of this register, so your buffer is just size 1, like this one, and you just send this value, you may or may not have a 0. And the only way for you to have a 0 is to actually send a 0. So you're going to send, your buffer is going to be, in my case, my buffer is a size 2 buffer. So my first value is the value of this register, which is also 0. And I am sending another 0. And by doing that, I'm going to receive a 0, so which is going to be stored in this value that I also called old mode, like here. And for the rest of the code, I'm following the same thing. I'm writing the value of the prescaler here in this transmit function. And to calculate the value of the prescaler, I am using the classic formula. If you've been watching my videos, you already know this formula here, where you have the clock divided by the auto reload register times the prescaler. And I may not have mentioned that in my previous videos, but the prescaler usually is, the minimum value is 1. There's always a plus 1. And even if you look in one of my timers here, for example, this one, I like to write my prescaler in this form. This is 3, but the actual value here is 4 because there's always a plus 1. For the rest of the code, I'm just copy pasting the same thing. Now, in the file, when they are calculating the value of the prescaler, they add a 0.5 here. I don't know where it comes from, so I prefer to stick to the classic formula where there is no 0.5. Now the second function, the set PWM. Here you have, this is the value of the pin you're going to use. The PCA has 16 pins that you can use, And this is the mode that they are using, and I'm also using the same mode. So to really understand this formula, we have to go back in the data sheet. So here you can see LED on L, which is 06. And this means that you're controlling the output with byte 0. And if you want to control LED 1 or pin 1 with byte 0 as well, you have to use the value 10. And from here to here, we added 4. And the same thing is going to happen with pin 2 and pin 3, etc., etc. So every time we're adding 4. And that's the reason why here we have here our starting value, and every time we have 4 times the pin you want to choose, and this will give you the address, the corresponding address. Now, another thing that's really worth mentioning is the PCA is only works with 8-bit values. All its registers is just 8-bit, and here you have a value which is a 16-bit value, and which is normal because your prescaler can go up to, your register, the value of your compare register can go up to 4096. So you definitely have something that's above 255. So in this situation, what you do is you're going to split that value into two different values. And you have to be aware of something really important here, which is the Endianness. Endianness is the way your microprocessor is going to write data in memory. And the majority of microprocessors are what is called little endian, which means that they start from the least significant bit to the most significant bit. And you have also the big endian, which is the opposite. So let's get a look at how it works with a very simple example. Here we have our 16-bit value that we want to send to the PCA. And let's assume that our microcontroller is Little Indian, which is really most of the time that's the case. A microcontroller is going to be a Little Indian. So let's store that value into something smaller, into an 8-bit value. So let's call that value 1. And what's going to happen is the processor is going to write starting from the end, from the least significant bit. So it's going to write D and it's going to write C. And here we're going to have an 8-bit stored into this value 1. And then we're going to write shift things from 8-bit, and our value is going to become this one. And we do the same thing, and we're going to store that into a second value. I2C is a first in, first out protocol, which means the first value sent is the first value received. So we're going to send value 1 first into a PCA, which is a little Indian. So it's going to receive DC. And after that, we're going to send value 2, BA. And at the end, we have our A, B, C, D in the right order. And if we were sending this data on a microprocessor that was big Indian, we would have had, starting from the most significant bit to the least significant bit, C, D, A, B. You have to ask yourself, how does your protocol work? On the sending end, what's the architecture of the processor? And on the receiving end, what's the architecture of the processor? Now, in my custom code, I don't use the value on. I do use on, but my on is always, I don't create a variable for that because it's always 0, because I always start at 0. So there's no point for me to create a value. But the off is very important. And if you watch my previous video, you recognize this formula corresponding to when I do the conversion from the angle to the compare register based on the duty cycle. I'm just doing exactly the same thing as here, and I send that into my buffer. And this is my PWM function when I'm using the PCA9685 to control my servos. One last thing that I want to mention is if you're sure about your configurations, about your code, that you define everything correctly, but your device is still not working, you may have a logic high level problem and you need to use pull-up resistors on SCL and SDA. Here I'm not using my a nuclear board, that's my custom STM32 board, and I have this pull-up resistance on my I2C pins. But I'm also using the internal pull-up resistors of the microcontroller as well.